In the video, you see our group calibrating the pH meter with buffer solutions of 4 and 7, which allow us to accurately measure the pH of our unknown acid. We started with our pH 7 buffer, stirring the rod in the solution and entering 7 into our meter. We then clean the rod with our distilled water and repeat with our pH 4 buffer. A buffer solution is a solution containing a weak acid and its conjugate base, or vice versa. They are used to prevent changes in the pH of a solution regardless of the solute.
Here, our group is each taking their respective steps in order to find the pH of our strong and weak acids. Strong acids will completely dissociate in water, and weak acids only partially dissociate in water. For example, HCl, or hydrochloric acid, is a strong acid. So in water, it dissociates into H+ ions and Cl ions. Weak acids will not fully dissociate because they have a small K value, so the weak acid is not able to fully donate all of its hydrogen ions. The reason this leads to equilibrium is because a strong acid is in equilibria with their conjugate base. In this example, our strong acid is HCl, and it dissociates into water, which is our conjugate base.
A strong acid generally has a pH level between 0 and 3. We found apple juice and orange juice to be weak acids, as their pH level is between 3 and 7. On the other hand, a strong base has a pH level between 12 and 14. We found sodium hydroxide to be a strong base. However, we found ammonium hydroxide to be a weak base, as its pH level is between 7 and 12. In the next exercise, we explored how changing concentration of acid affects its pH. We used hydrochloric acid as our strong acid, and we used acetic acid as our weak acid. We found that strong acids have a more drastic change in pH as their concentration increases, and we found that as concentration increases, pH decreases for acids. In the final exercise, we evaluated the pH of different solutions. We found tap water and hydrochloric acid to have a pH of 1.36, tap water to have a pH of 6.38, sodium hydroxide and acetic acid to have a pH of 4.43, and a buffer solution and hydrochloric acid to have a pH of 2.44.